Okay, so thanks for the introduction, Sergeant. My name is Gluhak. I'm a senior research fellow at the University of Surrey, where I work since 2006 on wireless sensor networks and IoT-related activities. I have the pleasure to present you, or the opening of this tutorial. It's a whole day tutorial about the SmartSantander facility. It's basically, I would say, Europe's largest facility for Internet of Things experimentation, which we've built over the last 3 years. And a lot of the things are now slowly coming together and are here in place. And I think now you have a unique opportunity to basically get a detailed overview of what is possible with SmartSantander and how you can use it for your research. This tutorial is, the first part will be done by 3 different people because we have different testbed sites, and I think it's just fair that those people who are best familiar with the testbed sites also give you the inside information about it. And so I will overall give you an overview now what you actually can take out of this tutorial. So on one side, it's important to understand the purpose of experimental research and how to actually run it and conduct it on a real experimental testbed, like SmartSantander is. Then obviously you should somehow gain as well unique insight how Santander is composed, what it's built upon, and also what are the tools available for you to use. And we will give you some examples as well what type of research you can do on top of it. And then we go a little bit deeper into basically the experimentation life cycle, how our tools can support you in this, and we also look a little bit about user-centered experimentation, something that is also increasingly becoming more important for Internet of Things. And in the afternoon, we have then a hands-on part. So it will be like 3 parallel sessions where we have basically, we have a very deep on, let's say, more hands-on approach on the different testbeds that are available as part of SmartSantander. And you can then, inside of it, basically learn a bit better hands-on how to actually do things on it. And the last part looks at, as well as at a more advanced topic. We've come up with a lot of, let's say, architectures and also software modules that we use in our testbed. And you could theoretically, if you want also to set up your own testbed, use those to do. And Daniel will present you also a bit more insights into it. So basically, 4 parts. This is what the tutorial is. The first part really looking an overview of SmartSantander. The second part really looking at experimentation on top. Third part hands-on on 3 different testbed sites. And the fourth part looks really at if you want to build your own testbed, how can you start off and how can you federate even with us. Okay. So the learning goals of the first part are to understand obviously why experimental evaluation is important for IoT research. Then also I would like to give you a little bit of an overview of the context. Where does SmartSantander fit in the European landscape and how it relates to other initiatives in there. And then we would like to go further into understanding what is the main purpose of the SmartSantander facility, and also then what is on offer. So what can you use, what kind of devices are there, what's the infrastructure available for you. And then also learn a little bit about the components inside and how they're used inside, and also examine a few examples of experimentations on it. So I started basically 2006, and I think at that time I was more looking at theoretic aspects, and I remember myself that and I think many European projects also follow this kind of approach, where you build up like a very complex type of new framework, new infrastructure, and new algorithms, and when it actually comes down to showing them in real life, there's often very little that actually works, or you can just demonstrate at the end of the project something very small. And this comes as well from the fact that theory and reality are sometimes 2 different things, and there are many more constraints that you have to consider if you want to run let's say, a solution in the real world. A lot of factors that you usually don't consider in research. So there's an increasing trend now that we have where experimental research is becoming more important, where you do maybe more hands-on research, try to prototype certain functionalities on a real-world testbed, try to evaluate, refine. So your requirements are not somewhere in the sky, but more grounded to reality. And this is driven by several trends. One of the trends is basically that there's a, I mean, you say that the research pace is increasing in the recent few years. So there are much more shorter experimentation cycles, also research cycles when you want to, let's say, come up with a new solution and then bring it to the market. And if you do experimental research, this can be helpful to shorten this kind of development cycle. Another thing is as well that more and more increasingly you see also smart technologies being deployed in the wild. And another one is basically that more and more experiments also now rely on interaction with end users, real end users who will use this technology. And this is something that you can very difficult to simulate in a simulator or an environment. You need really to go out to the people, to interact with them, deploy the technology, try to get their feedback in order to make something that is also accepted by the society at large. So also a few other arguments for you for experimental research. If you look, for instance, at the top 2 or 3 or 4 conferences in the area, I've just picked 2 examples, for instance, Census or PERCOM. You cannot publish any more results there. They're just based on let's say, on simulation, or are basically from theoretic or synthetic traces or models. For instance, Census, 21 of the 22 past papers used experimental evaluation. Only 1 paper used basically simulations based on TOSIM, and there's also a more hardware-oriented emulator or simulator for use. Likewise, PERCOM, you have basically also a large amount of experiments that have been carried out on real devices, be it sensors deployed in the environment, be it mobile phones, or even mixed cases of this type of experimentation infrastructures. And although there's an increasing amount of simulations still there, so 9 of the papers used actual simulations for evaluation, all of them were based on real-world traces. And real-world traces, again, are collected through real devices in a real environment, and testbeds can be used for this. So just to get you a little bit an idea how important actually experimental research has become. Obviously, there are various benefits. On one side, experimental research allows you to bridge theory and reality. So you can basically start off with some maybe more realistic requirements, do your research, you can experiment with it, validate your ideas, and then feed them back again into your requirements. So this ends like a kind of experimental research cycle where you slowly converge to something that is basically applicable and also for real-world use. And one of the main difficulties that you encounter when you do, let's say, simulation-based studies, or if you do, let's say, more theoretic analytical work, is that it is very difficult to model reality in its entirety. So often, if you do, like, let's say, this type of research, you take maybe idealistic assumptions, or maybe assumptions sometimes that are wrong. And this may have an impact on your protocol that you develop. Also, there are certain implementation constraints that you got. So, for instance, you assume you have some form of fixed or let's say floating point calculations in your protocol. Some of the, let's say, MCUs or some of the systems where you would deploy those do not support such calculations. You just have maybe integers to play with. So and they will have an impact on the accuracy of your protocol and what you do. Likewise, it's difficult as well to kind of simulate all different types of real-world conditions. So it's difficult to model the real world in its entirety in your simulation scenario. And these are all arguments why making basically realistic experimentation is important. So on one side, if you do assessment as well on a real world testbed and you do solutions on a real prototypes that work for real, you have increased credibility. So people cannot question anymore, let's say, the assumptions that you take or certain, let's say, constraints that you assume it works for real in your test bed. You can show them that you've demonstrated it works for real. So that's a very big plus point. Furthermore, it's easier as well to adopt your outcomes because if you have a working prototype, you can just share it with others in the community. People start then using it again for their own research, so your research becomes more adopted. That is also, let's say, a second argument which is good. And you have obviously a faster path to a market. So you have a research prototype that you can then maybe take into a product if you're interested in spin-out. And today's business session hopefully will give us, or this week's business sessions will give some insights here. And it's basically also easier to attract, let's say, investment or funding if you have something to show that works for real. So this is just a little bit about the motivation behind why we want to do experimental research. Obviously, in Europe, let's say, there's this large FP7 program which is currently coming to an end. And as part of this overall research program, people have also started to, in our area, look at experimental research. And there's a program called FIRE. It's called Future Internet Experimentation and Research Environments. And this FIRE program is about being able to build certain infrastructure testbeds for experimental research on internet or future internet solutions, which are basically networking paradigms, architectures, as well as services around this. And I think a main motivation as well is, okay, there's a lot of evolutionary type of research that you can easily, let's say, validate. So you can just build upon existing infrastructures to do it. But what do you do with new paradigms, new testbeds, or let's say new paradigms that you cannot test on a normal commercial network? Let's say technologies that are disruptive, that change, for instance, certain assumptions that you take, like, for instance, IP being part of the internet. And for this, you require some more advanced experimentation facilities to do this type of evaluations. And so FIRE pretty much try to support building such facilities where you can play with new concepts, where you can then validate them, you have some real environment where you can test them, and you're not constrained from the current implementations of existing infrastructures. And obviously, another aspect of FIRE is to better understand socioeconomic issues that you have with, let's say, the proposition of new protocols, solutions, and so on. And a real-world testbed allows you to kind of consider users, take them into the loop, and then also understand better what is the acceptance issues that you encounter, or also what kind of issues you will have, let's say, with the technology that you have if a user uses it in a certain way which you didn't anticipate. And believe me, users use technologies in many ways that you don't anticipate. So the overall approach from FIRE was to fund, on one side, the building of new experimental facilities, and then also making these facilities, let's say, publicly accessible and sharing in the community. And I think part of this event today is to somehow open this up to a wider public audience, and hopefully some of you will try to use what we've built one day in their research. But it's also to support collaborative experimental research, and also try to have some way of performing, let's say, experiments on your facility that push the boundaries of it and give new requirements how the facility should evolve. And so these kind of instruments were basically provided by FIRE and its projects themselves. And if you look at this larger landscape, so there's quite a large number of FIRE facilities available now for different types of research. So on one side you can see you have things on sensor networks, Internet of Things, testbeds. SmartSantander is basically the, let's say, leading testbed in this area. But you have other testbeds across in these FIRE ecosystems that look maybe at networking protocols, at new wireless technologies, cognitive technologies, cloud-based systems, and so on. And all these testbeds are actually available for you to use. You can go to the portal, you can start playing, accessing, requesting access to these testbeds. And if maybe some of your research may also require combining these testbeds. And there are also some initiatives now, which like the Fed for FIRE, which tries to federate testbeds and functions, so you can actually run experiments across these different facilities. Okay.
So, but the facilities are inside our
all these facilities have been constructed by a European project. But the idea is that they somehow become sustainable beyond the project lifetime, so the public can use them. So, for instance, SmartSantander or other facilities have some exploitation plans as well, which want to provision the facilities beyond the project lifetime. So some of them are maybe free use models, some of them may require charging at some point for the services they offer if there's certain uptake. But there are certain arrangements where every one of us has pledged to somehow make these facilities available beyond project lifetime. Okay. So apart from funding these different facilities, also FIRE has funded various research projects, which in part make use of these facilities and basically do research in these different areas. And so that's basically an overview of a lot of different projects that have been funded now in the last 2-3 years and are still ongoing, which do some form of experimental research. And it may be interesting for you as well to have a look what they are doing, so you can relate somehow your own research to, let's say, those projects in a particular domain. Apart from those, there has been also a very special arrangement with FIRE that each of the facilities themselves had some funding available to fund experiments proposed by the community. So there are other, let's say, smaller scale projects, maybe limited to 6 months or 1 year, which try to do some form of experimental evaluations on top of these different facilities. And in Santander, for instance, in our testbed, we have currently, I believe, 4 new projects ongoing that kind of make use of this facility. And these are also very good starting points for you to explore what they do, how they use us, to understand what type of research is possible. Okay. So now when we look now, maybe a step back again, so the FIRE presented the overall future internet picture, but now going now into the area of Internet of Things per se. There have been quite a lot of testbeds around since let's say, I think the early 2000s. And you had testbeds mainly more focused on the wireless and the network domain. And many of these testbeds were lab-based testbeds. So researchers could run the protocols, but the environment in them, where they ran this their experiments were quite constrained to a building, to a lab, or such an environment. So in future, what we believe is that future internet, or let's say Internet of Things experimentation, requires also an extension of these environments to maybe outdoors, to other areas, so you can capture all this, let's say, the realism from these environments in your facility. So SmartSantander try to do this, let's say, in a city context. So moving it out to the outdoor, to a city environment, to buildings, to kind of converge into this dimension. Furthermore, the Internet of Things will not be just wireless and the networks. So there are quite a few technologies emerging. The idea is it's kind of a heterogeneous, let's say, substrate of devices such as sensors, actuators, embedded nodes, embedded gateways, mobile phones, RFID tags, and so on, all contributing basically to, let's say, a pervasive infrastructure that can capture real-world information and integrate this into your applications and systems and services behind. So testbeds have to show this type of heterogeneity. Furthermore, if you then start moving from lab to a city, you need to also scale your solutions in a different environment. And also, in order to assess scale, you need a testbed that offers you this kind of capabilities. So more devices is important, and maybe devices that are realistic for what you want to do. Likewise, mobility is also an issue that people are facing, and there are maybe some testbeds that offer some form of robots driving around, or some form of, let's say, controlled mobility patterns. But in reality, you want also some form of realistic mobility patterns that you have by people walking around in an environment, cars moving around, and so on. So this type of things should be somehow also captured in your testbed. Then testbeds should be, obviously, it's a very expensive infrastructure. They should support concurrent execution of experiment. So you can maybe run 5-6 experiments on the same infrastructure. Maybe not the same nodes, but at least the testbed as such is an infrastructure. So you can better utilize the expensive resources for your experiments. And this has certain challenges that you need to address. Also, another challenge is how can you repeat an experiment so you get the same results, or how you can actually reproduce them across different testbeds. There are also challenges that need to be addressed, and things that have to be taken into consideration. And I think a final point for me, which is very important, is a testbed should be somehow close to its end users. And you need to be able to somehow introduce the end user as such into this experimentation life cycle. Either just by being passive, carrying, for instance, certain devices around with you, or by being active, even, let's say, providing input, feedback, or being, let's say, an endpoint of the experimentation. And we hope about this user-centered experimentation, we can give you also some insights as well as part of this tutorial. So all these things have been captured in one of the survey papers that our project has published in this space. So maybe just before going to SmartSantander, just have a look at existing, let's say, IoT or wireless sensor network testbeds. So I've just picked maybe a few of them, maybe the most commonly used currently in the environment. So Senzations is a US-based testbed, which is based on a Kansai testbed and NetEye testbed. So these are two university deployments that are combined to an experimentation infrastructure. And it offers you already quite a large number of modes, so like roughly like 600 experimentation devices that you can use for your experiments. However, in terms of environment, it's mainly indoor and lab-based. Similar, SenseLab is a French project which kind of federates 4 different testbeds across 4 different in-real testbed sites. And here again, you have different nodes, but they're all modes, wireless sensor network nodes, with I think half of them have a certain MAC, like an 854, another one are MAC free, so you can play at least there with some heterogeneity, but overall the testbed is quite homogeneous as such. WILabT is also another testbed, which I believe is from, it's an institution in Belgium, a research institution in Belgium, IBBT. And it's also like an indoor testbed, 200 modes that you can run through experiments. So as you can see, Twist is one in Berlin, provided by TU Berlin, and WiSped is basically a former European project that has created basically a federated testbed, and WiSped technology has been also be used in SmartSantander as well, that provides the foundation of things that we have done. And it's one of the testbeds that has now some auto deployments as well available for experimentation, and quite has a large scale of heterogeneity. But overall, looking at it, you can still see, according to these different requirements and dimensions, there's quite a large gap of what the testbeds can offer and what actually future experimentation would require in this context. And SmartSantander has tried basically to close this gap in multiple dimensions. On one side, for sure, on heterogeneity, on federation, but also in terms of scale, mobility, and overall the realism of the experimentation environment. Any questions so far? Okay, so we've been talking a lot about SmartSantander, so what is it exactly? So it's basically a project that has started 3 years ago. So I think just yesterday, or was it the day before yesterday, Stefan told me, was where the official 3 years period ended of the project. So, and the idea was basically to somehow create a realistic testbed for IoT experimentation. And it should be a testbed. Our vision was that it's large scale, that people can use, and it has a certain realism that other testbeds don't offer. And we choose to implement SmartSantander as a smart city testbed. So somehow to embed it into a city environment, and in this environment as well offer different types of support for services. So what we target is not only researchers to do some form of experimentation with let's say protocols or system level types of research, but also to do experiments with services. And also service providers, like for instance also small SMEs and companies could use this testbed to build maybe new ideas for applications and services that they can offer to citizens or to the city themselves. And we wanted this infrastructure as well to be used by end users. So this means the city itself should benefit from it, with basically innovation coming from it, but also the citizens themselves should benefit from it. And it's a quite large consortium that consists of various partners, big industry, universities, research centers, all combined. And so we were 15 organizations from 8 EU countries, and also an Australian partner in the form of the University of Melbourne was involved. And I think maybe just to give a bit also an idea why we choose to go for a city. So we believe that a city itself is a very interesting environment because on one side it provides you like different types of exposure to application domains. So it's just not like an environment which is limited, let's say, to one IoT application domain, like, for instance, transport or logistics. But I think a city combines all sorts of things, ranging from transportation over to governance, over to how, for instance, energy is managed in the city, how people live in the city, and so on. So it's a cross-cutting environment where where you can do different types of technology research. And that's one of the thoughts why we would like to deploy a testbed in the city. On the other thing as well, we think that the city is an excellent catalyst for also research. On one side, you have large number of critical users that would adopt the technology. Also, people in the city tend to be a bit more, let's say, ahead of time than, let's say, things in rural areas in terms of adopting technologies. So you have the early users there sitting, and that is something that we wanted to tap into as well. And that's another argument why we wanted to have an IoT testbed in such an environment. And the last bit is also that IoT, or the benefits of IoT, would become visible as well to a large number of citizens or users in Europe. And it's also another dimension in terms of impact, why we choose this kind of environment. So different reasons for it. So I've talked, so what is it? What do we offer? So we've built a testbed that consists of a large number of Internet of Things nodes. And I mean, I think our initial target was 20,000 IoT nodes. But I don't know the exact number at the end. Louis may tell you a bit more later about this. But I think we have a significant number of sensor nodes deployed in an environment across 4 different testbed sites. There's a main deployment in the city of Santander, and then we have also 3 additional deployments, one in Guildford, one in Lübeck, and one in Belgrade. And they all have their certain sweet spots, and they all focus on slightly different aspects of IoT experimentation. In essence, what you will find are IoT devices that you can use, for instance, for smart traffic, parking type of scenarios in the city. You have nodes that can provide environmental monitoring, as well as maybe looking at smart street lighting type of applications. You have also irrigation systems deployed in parks and motion sensors where you can optimize also intelligence in this type of environments. You also have mobile experimentation nodes. So nodes mounted to buses and to public service vehicles that drive around the city, where you can also tap into the data flows and play with them. And you also have basically deployments that are more, let's say, building oriented, where you have basically can do smart building type of research, looking for instance at energy monitoring in the environment, optimization of energy inside of buildings, or creating just smart environments where people work and live. So it's kind of a heterogeneous testbed that offers quite a lot of potential for different types of research. So, I mean, I've tried to kind of highlight already from my talk a few of the key features. And apart from, let's say, the heterogeneity of the hardware and environments that we offer, I think a unique thing is it's something that is deployed in the wild for real, and that is basically embedded in environments where people move and where they work, where they live. So, and this type of societal penetration is very difficult to get usually in lab-based testbeds. So, for instance, it will allow you to get people using, interacting with technology, but also it will allow you to monitor maybe parameters or aspects of behavior of people, or what implications of their behavior. And I think this is what I mean with societal penetration. Something that is, let's say, quite interesting ground for let's say, new ideas that are hopefully also adopted by society easier. Then we offer also more realistic mobility patterns We have, let's say, an unprecedented scale in terms of the testbed devices available for you. And also, I think something of value is that a lot of the services actually are supported by, so like new services are actually supported live by the infrastructure. So if you get to a stage where you, for instance, run an experiment for a service and you prototype it and it works well, and let's say the city likes it or citizens like it, there's a high likelihood that you can actually have this service running beyond your experimentation life cycle. And there are certain sustainability plans there in these infrastructures, and obviously there needs to be some discussions about business arrangements and so on, but it is possible, and we've already demonstrated this as part of the first 3 years of the project. And I think a good unique is the diversity of experiments that we can support. So you can really make research maybe on IoT protocols, let's say information processing protocols, or let's say new communication or networking protocols inside of the Internet of Things or embedded devices. But you also can do service experimentation. So you can, maybe look at services that utilize IoT data or that trigger actionable things in the real world through actuators. So it's basically on a higher level, you can also utilize this testbed for experiments. And you can also perform tests and experiments with users in the loop. And I think this mix of these different things, I believe, makes this testbed a really exciting environment. Okay, any questions so far on this? Or? Okay, now I'm going to dive a little bit into the architecture. I know it's a heavy picture. I will just spend a little bit of time on it. There's plenty of documentation as well available online where you can read more deeper into it. But I just wanted to try to give you a brief touch on the different types of system components running. So on one side we have 3 different layers. We have basically some form of testbed server that offers a basic set of functions towards experimental end users and interfaces where then different experimentation clients or administrative clients can connect, or also where service provider clients can connect to. And then we have basically another tier, which is a gateway tier. These embedded devices that are closer to the IoT devices themselves. And you have a lot of functions running between these testbed servers and these gateway devices to make sure basically that certain experimentation support functions are provided. We also have, in some cases, functions even on the IoT node themselves that are able to provide also then data back into the system in a certain way, or where you can basically easier manage things like mobility, fault management, and this type of stuff of this platform. So on one side, if you look at the experimental user client, you have functions that are there to configure an experiment, to basically then help you to do a session management, so deploy, monitor, run an experiment. And you have also functions that allow you to analyze data coming from the experiment. And on the other side, if you're like a testbed administrator, or so you have your own testbed, or some people of us, we have also access to the testbed resources themselves. So manage those resources that they become available in the testbed. What kind of capabilities do they have, and to register this to make it accessible then to the experimenters themselves. And then we also have basically some functions that are more some form of service platform functions, where you have some cloud environment that runs, let's say, a certain service platform from Telefonica, the IDAS platform, where you can then, as a service provider, go discover your data streams that are available from your testbed, and then also do some form of smart combination of data and basically run and host a service. All these functions are kind of offered by this architecture. And the final bit on top of it is as well federation capabilities. So if you're not a native SmartSantander user, so let's say use it through one of our testbed clients, for instance, but let's say you make an experiment in another Fire testbed, like Ophelia or like Bonfire. There are certain as well interfaces functions that allow you then to access also SmartSantander functionality across these different testbeds. These are this type of federation functions. Okay, so maybe also to give you just a little understanding, so there's these 3 tiers: IoT node tier, gateway tier, server tier. And you can logically see there are 2 different planes. On one is basically the IoT experimentation plane. And this is what you define. So it's up to you to specify, this is your experiment, this is your protocol, this is your service that you want to run. And your service may, for instance, have for sure some application logic that sits on a sensor node. It may have some, or may not have some logic that sits on a gateway node, and it may or may not have logic that sits on application and data server. And on top, we offer some form of testbed observation and management plane that allows you then to basically monitor the behavior of your experiment at the different levels. Okay, so for instance, and also control to a certain extent the behavior of your experiment at different levels. So, for instance, on the server tier side, we have all these testbed management servers that you can see that you interact with the functions. There's also some parts of this testbed runtime environment that runs on the gateway itself. And through the gateways, often we observe directly the IoT nodes, but there may be also some additional hardware that can be actually attached to, for instance, observe how your node performs or inject certain real-world events into your node. So this is this type of, let's say, 3-tier architecture with these 2 different planes. This is something that you have to imagine testbed offers. So that is something I will just briefly show you. The implementation architecture itself, how the components are actually built on these different planes. And I will just maybe focus on 3 different parts. One of them is basically service level experimentation. And here we refer to experiments that really use mainly the data. So here you maybe are not interested in really touching much on a sensor node. You're just interested in the data that the sensor node provides. And you're happy just to use, let's say, some default data streams that are generated from the testbed. Or maybe you can task this. You can say, okay, I want my data once every minute, once every 2 minutes, or once every 10 seconds. Depending on whatever hardware this is, there are certain limitations that you have to consider. But then your main experiment consists of, let's say, using this data in a service, combining it, let's say, intelligently trigger some actionable real-world event or anything like that. Then node-level experiments are, let's say, or system-level experiments where you really are interested in, let's say, the protocol, the algorithm to run on the nodes themselves in the sensor network, maybe on the gateway devices. And you're interested in understanding the performance of them and measuring them inside. So that's kind of a different level of experimentation that is supported by these testbeds. And the last one is really where you maybe look at it's more social people-oriented experimentation. And here, for instance, so we, as an example, is we have applications running on smartphones of citizens in Centar. They deliver data at a certain rate and so on, and you can tap into these data streams and analyze and do things with it. So, so these 3 different types you can imagine, and in these 3 different types, the architecture supports you also with different features. So on the service provisioning side, you usually are like, let's say, a service developer or like at the end a service provider, where you can access data coming from the different testbed through this SmartSantander cloud platform. And there's some form of experimentation level, service level experimentation manager that deals basically with different subscribers and make sure that things are enforced in terms of, let's say, the certain service level agreements. And so the platform set is based on Telefónica's IDAS platform, which offers basically a certain API to you to basically discover sensors, access sensors, the information streams, and then do something with it. And usually those components tap into let's say, our SmartSantander portal server, which offers basically a directory of different resources, so experimentation resources. In the end, nodes and sensors, what is available. That then basically is automatically imported into this platform. And then on the lower level, you have different ways of basically aggregating data flows coming from these different sensors. I will not dive into detail here, but just to give you an idea, and maybe if you're really interested in it, you can do this maybe later in the documentation. Then there's another subset of the system which really looks more at the node level experiments. So these are the experiments that are usually supported by existing wireless sensor network testbeds, also WiseBed. We use a lot of the WiseBed components actually, which have been developed in this WiseBed project in these testbeds, and we've enhanced them basically for our new requirements. And here you are more interested in, for instance, how to, on one side, reserve resources, individual nodes, how to reprogram them, reflash them, how to then basically execute code, monitor your experiment, or influence your experiment. And so it's a different set of functions that we'll use then, in this platform for running these. And then also, slightly connected is basically this social experimentation, or let's say the user-centered experimentation, where you can drag basically also information from mobile handsets of users. And in particular, let's say, from those data streams that are provided by some form of participatory sensing applications that we have, or also augmented reality applications that we have in the city of Santander. And these data streams are also accessible to the platform through this Telefonica IDA system. Okay, so I know it has been a lot of information so far. I hope you had now a brief overview as well on why IoT experimentation is important, and also the overall European picture in terms of FIRE or experimental research facilities, how SmartSantander fits into it, what SmartSantander is about, also what are the components, what's the big picture of the SmartSantander facility, and I think from now onwards I would like to dive more into the individual testbed deployments. So as I said, there were 4. Santander is I think the main deployment with the largest amount of sensors, and this is the real, I would say, in the city deployment that you can tap upon. And I'll pass over now to Luis to tell you a little bit more about it. Later I will be speaking a bit about the Guildford deployment, and then we will also have Daniel presenting the Lübeck deployment, and Stefan at the end will explain you as well about the Belgrade deployment. And that will then overall wrap up the first part of the tutorial.